Yes, we can see your screen.
All right, so this is the topic I'm going to be working on. It's creating a multi-speaker podcast with Gemini 2.0 and text-to-speech. Like I said, my name is Daniel Calvin Mubvumbi. So let's go. So I structured my presentation into four main concepts, or a table of contents rather. I have the introduction and overview, the main idea, which is creating a multi-speaker podcast, and the main components involved, and then we'll do a Colab walkthrough. So the introduction is very straightforward. Like I said, I'm going full beginner and basic. So for starters, let's start with introducing the concept of AI. What really is it? So by definition, loosely, we're saying that we're talking about computer programs that can learn and perform tasks that really require human intelligence. So we're talking about understanding language, recognizing patterns, generating content, basically your day-to-day activities and tasks that you do as a human being. So those are trying to be mimicked by a computer. So that's AI. The artificial part of it is that they're usually done by humans, but it's a computer trying to do them, hence artificial intelligence. So in AI, there are several types of it, and one common concept that we often come across is generative AI, where we are saying AI has the capabilities of creating new things, of creating text, creating images, or even audio, which is going to be our main focus in this presentation. So the idea I'm going to be working on or presenting on, it's creating a multi-speaker podcast generation. Like I said, it's generating audio basically from text, or generating the text first and then transcribing the text to be audio. So AI is capable of creating or generating realistic sounding voices. So like we said, when we defined AI, it's all about mimicking human intelligence or mimicking what humans are capable of doing. So you would know that as humans, we're able to produce audio through our voices, yeah? So AI is capable of recreating those voices as well, of generating them from maybe text or from other models like to speaker podcast using AI. We have a number of ways we can do it. We can provide a script, which is in text format. We can feed that text into a model. In this case, it's the text to speech. The text to speech from Google or Gemini 2.0 Flash, then it will generate audio from the text you would have given it. So it understands the text and it produces voices from that text. Or another way to do it, you can give the AI a prompt, and the Gemini 2.0 Flash will generate a script for you, and then that script will then be generated into audio by text to speech. And then the key concept we're going to be focusing on is we'll be using the Vertex AI API, which gives us access to TTS, which is text to speech, and Gemini 2.0 Flash. Like I said, I am Google Cloud certified, so Vertex AI, the API part of it, gives you access to all these modules when you're using Google Cloud. So the main reason, I think, one of the core components that this presentation was wanted to show was that you don't need to have heavy compute for you to use Google models, or for you to start using your AI, because you have Google with their models and with their computers already to step in and help. Like the Vertex AI gives you access to all the models that Google offers. So I could have used Hugging Face, I could have used LangChain, but frankly, I really had no appetite to go through that. So we'll go straight into the Colab walkthrough. Sorry. Confirm you can still see my screen.
Yes, we can still see it, Daniel.
All right. So I'm not going to be doing any demos because this required me to have Google Cloud and the working billing, so I can't use my one from work in case I get billed for that. So I'm just going to be walking you through the Colab notebook and explain just a few things that are happening. So again, this is publicly available. You can just Google it, copy the link and open it, and you get access to it as well. So as you can see, we want to create a multi-speaker podcast with Gemini 2.0 and text-to-speech. So Gemini 2.0 is one of the modules that comes from Google. It's one of their core modules that they're publishing. It's open source. And then text-to-speech, we have been using this for the longest time now. Maybe via our assistants on our phones and stuff like that. So this shouldn't be new, but the new part should be that we are now using it we're now customizing it so that we get a specific use case out of it. In this case, it's creating a multi-speaker podcast. So just an overview, I think you can read this through. So the steps performed in the Colab include loading a PDF file from the storage bucket. Again, this is a storage bucket is some sort of storage that you have in Google Cloud that you use to store your documents, your files, your media files and stuff like that. And then we summarize the contents using Gemini 2.0. So the PDF contains the script that we will be using. So if you come to the sample documents, sorry, I haven't connected to the runtime. I think it's connecting. But if you come here, you should be able to see some sample data that you'll be using. In this case, these are with CSVs and we also have JSONs. So you'll be using this data in the Colab. Again, all this is provided for you once you want to start exploring with the Colab. And then it then returns a predefined JSON schema for control generation. As you can see, if it's highlighted like this, it means you can click on it and read more information about it, if you will. And then also we're going to create a multi-speaker conversation from the JSON script using text-to-speech. So there are two components involved here. We have Gemini 2.0, the model, and then we have text-to-speech, which is now going to take the text and then create audio out of it. And then we also have some more information here. And also, please note there's an important note here. Generate dialogue with multiple speakers is only available to projects in allow list. So if your project, your Google Cloud project is not having this option, that means it's not on the allow list. You can contact Google Cloud if you want them to activate it for you. I think
Hi,
you should be able to
Daniel.
do that. Yeah.
Sorry to chime in. I think I can see your slide, but your slide is on slide number 4. We can't see the code you're referring to. Am I the only one?
No. That I was assuming you're seeing the. All right, let me do this. Let me reshare. Right, confirm you can see the lab now. Hi, Rimbo.
Sorry about that. Yes, we can see.
Right. So, okay, this whole time I was thinking you're seeing my screen. Let me just do a run through of what I was saying. Like I said, we have the sample data. You find it when you go to the files on your lab. When you open the lab, usually it's dead, so you'd have to connect it on the button right here. So it has all the instructions that you would need. If there's any more information you need about any subject, you'll find most of the subjects they have links for you to open and read more about that. About the Gemini API in Vertex AI, we have the link I just opened. I'm sure you can't see that as well. Yeah, you have to do that. So as I was explaining everything that's on the Colab, so you can just read through it when you find time, and then you see what's happening, what's up there. So the first thing we do is we install the libraries that we want to use. In this case, we are installing Google Gemini and Google. Again, installing these does not mean you have access to them immediately. Like I said, you the way we're accessing these is through the Google Cloud Vertex AI. So the Vertex API will then give you access to them. As you will see, once we get to this section, you then have to put your Google Cloud credentials on the notebook for you to get access to it. So when you open Google Cloud, you create a project. Your project will have a project ID, and it will have a location that you choose, a location of your choice. So it's usually encouraged that you choose the location closest to you for latency's sake. So once you figure these out, your project ID and your location, you also have other credentials that you then have to use. I think if you have the project ID and your location, it then takes those to figure out your identity, your Google Cloud identity as well. So that will be sorted. So this is all about providing your Google Cloud credentials that will give you access to Gen AI, which has the module, the Gemini 2.0 Flash, and which also has the text-to-speech component of the project. So you then define a client that will use the credentials that you just passed in the Colab. And then after that, remember, you'll be running all these sequentially, step by step. And then you import your libraries. So we have an audio library, then we have client options, which is one of the main we use. I'll show you what it's working for at the very end. And then also have text to speech, again, one of the main components. And then we have generate content type config and part. All these are coming from Google Gen AI types. This is the one that's giving us, this is the one we just installed, without using the Google Cloud Vertex AI API, sorry. And then this one is coming from Google Cloud, the text to speech. And then this one again is coming from Google Cloud, the text to speech, the client options again. So for these two, you need to have Google Cloud for you to use them. So again, my apologies for not being able to demonstrate this. I just scared to be built. And then we have, we then load the Gemini 2.0 Flash model, which is our main model that we're using to generate the content. So you will find, we find the model ID here. And while we are now defining our system instructions. So when we are creating these generative applications, what you have to do is you have to give context to the model so that it knows exactly the role that it's going to be playing in the use case. So in this case, we're telling the model that it's a podcast writer. Then the task is to generate a short podcast style dialogue between two speakers, speaker R and speaker S. So that's the context we're building we're giving to our model. And then we also have the studio's, I think this is just random voice. You can change it if you will. Again, if you open the documentation for text to speech, you'll be able to change this. And then we have a helper function. So this helper function, what it's doing, it's taking in a prompt and then it's passing it to the model that we have defined. So I remember on top we're passing the context and now we're passing the prompt. So we're telling it that the dialogue should be engaging, natural, stuff like that, and use the following information to create the content for the podcast dialogue. So we're feeding that to the model, and then we pass that, and then we ask it to generate the dialogue and give us in JSON format. So JSON is a data type that we use in programming a lot. And so we retrieve that dialogue as JSON format. So what we've just done here is we have given the model a prompt, and then it has given us a dialogue or a script rather for our podcast. So you can think about this as going into Gemini, the application, and then just typing in, "Hi, can you give me a script about blah 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 with speaker R and speaker S, give me in JSON format." Then you press enter, then it gives you the results. That's basically what we have done here, but in code format. And then we do a synthesized podcast. So now what we're doing is we're taking that dialogue. So you remember, a dialogue is a conversation that is ongoing between two people, yeah? So we take that dialogue and then we're feeding it to this function we've defined. We've defined a function synthesized podcast. Now we are giving it that dialogue so we're text to speech client to change the audio. So this is what this function is doing here. So we're defining the multi-speaker markup here, and then text to speech multi-speaker again. This is a function that is there in the text to speech module from Google. So text to speech multi-speaker markup. It's there. You don't have to create anything for it. What you just have to do is to make sure you pass in the data, and then we collect the response from here. And then after we collect the response, we then create an audio file. So on this line here with open, this is just us opening a file, and then we're writing to it, and then we're writing to it, and we're writing the response.audio content to it. Then we print at the end audio file written to the output file. So once you run the script successfully, or the labs of this part successfully, you should be able to see a file right here, an MP3 file with with your with your dialogue. And then now we're calling the text to speech API. We're calling the text to speech API with the script content. So this is again the same thing we're doing on over there at the top, passing the dialogue to text to speech, and then outputting or exporting the audio file. So I think that's it from my end, and I'll open the floor for any questions if we have any.
Daniel, so can I chime in here and co-present with you? I had done something to do with the audio, so I could share my notebook on the screen and then just showcase block by block what you were saying and taking everybody through. I think we used similar logic. Is that okay?
That's okay.
Awesome. So I'm just waiting for it to connect from, I was joining in via mobile. I just need to connect via the laptop and then we'll be ready to go. So just a moment there. So maybe the first person can ask a question. Righty. Sorry, can you hear me without the echo?
Yes, yes, Ron, we can hear you without the echo.
Awesome. All right. So here we go. Daniel, I would like you to help me out here as we could do this thing. As I was listening in, I understand you figured out text to speech, or did you use TTS? It's the same actually, yeah. You use the text to speech, right?
Yes, it's the same thing.
Awesome. So in this particular version, Daniel highlighted that you first give it a prompt or text to showcase. In this case, I was working on text that is in French. So I've got my text at the top here, and then I've got my language defined here, and then right at the bottom, after I run it, it's going to create a file. In this file, we just gave a name, which is output MP3. Yay. Okay, just a moment. It looks like I may need to just run this code here at the beginning. Looks like that ran. Ah, all right. All right, so it's acting up. Let me just leave it there. So when it runs, it creates this output MP3 file, and I used this library to display the audio. So I'm not so sure how this works, but if I click on it, just let me know.
Audacieuse en 5 secondes, redéfinie par rouge. Audacieuse en 5 secondes, redéfinie par rouge.
Could you hear the audio?
Yes, yes.
Yes, we can.
Hello, anybody? Oh, Carlton, thank you. Um, cool. So what you heard there was French, and I was playing on a notebook trying to see if we can create different adverts in multiple languages by comparing different types of copy. So that was an ad for lipstick in French. The lipstick is called Rouge. So that was just for one voice. Then I went on to create a multi-speaker audio, like how Daniel was demonstrating. So we have our two hard coded here. Ideally, you want this to be a JSON file that you read so that it's conversational. In this case, we're just trying out an advertisement, and we've got that in English. Got two voices that I use there. There's one that I absolutely adore. It's called Core, love female voice. And then I use the default there, which is WaveNet for the male voice. So after setting this up, I'll get um, two speech files, one written speaker, one the other one speaker two, just for context. And then from there, I can then combine it. And after I combine that, I will be able to get this. So I'm going to.
She is so confident.
Need power move? Red by rouge.
She is so confident.
Need a power move? Get red by rouge.
So the whole idea of it is if you then have a longer script, if you have longer text, you can turn these into 4 or 5 different characters. And at the bottom now was an experiment to see if it was below. So yeah, where we've got the errors. Thank you. So where we've got our experiment is here, and we're trying to see if we can properly prompt And based off the prompt, it then generates the number of speakers that are needed. Then from the script, it then shares the audio that is needed using Gemini 2.0 Flash. So yeah, this is what I was, and that audio would have been something that you would have heard from Daniel if you had run the models. And yes, it is paid. I'm using credits. So if you're a first time user of Google Cloud, you get free credits. Or if you're taking some of the Cloud Skills Boost courses, you also get credits. So I'll hand the session back over to Daniel.
Right. Thank you so much, Ruimbo. I think Ruimbo and I will take questions if there are any. All right. I guess silence means no. Thank you, guys, and back to you, Chair.